Hello and welcome to this video on finding critical values. In this video, I would like to show how to use StatCrunch to find critical values regarding hypothesis tests. First, I'd like to talk about finding the Z critical value. And the Z critical value is used with proportions. So whether we have a single proportion or a double proportion, to compute the critical value is going to be the same way. Second, I would like to talk about computing the T critical value. The T critical value is used with means. So whether you have a single mean, this will work. Whether you have two means dependent or two means independent, this method will work. All right, so let's just recall that the critical value is kind of the fence line between the rejection region and the non-rejection region. So if your test statistic falls in the rejection region, then recall you will reject the null hypothesis. If your critical value, if your test statistic is smaller than the critical value, then the test statistic falls in the non-rejection region. So in that case, you will fail to reject. All right, so now let's go ahead and talk about computing these critical values. And I'm going to start off with the Z critical value. So again, this is regarding a single proportion or two proportions. So we're going to come up here and go stat, come over to our normal calculator. And in this case, we are given an alpha level of 0.05, and we are informed that this is an upper tailed test. So what we need to find is what is the fence line then that shades that upper area with an alpha of 0.05, which is going to be your rejection region, and anything below that is your non-rejection region. So I'm going to change this since it's an upper tailed test, so this would match the alternative hypothesis. I'm going to clear this out, and I'm going to make this a 0.5. And then we'll click compute. And notice that this right here, our red area, is the rejection region. And the fence line is right here. We draw the line in the sand, all right, and that is 1.645. So if your test statistic is greater than 1.645, then your test statistic falls in the rejection region. If your test statistic is smaller, then it falls over here in the non-rejection region. So let's take a look now at alpha is 0.1. So I'm going to clear this out. We're sticking with the Z, but we have a lower tailed test, so that means the lower tailed test means that the hypothesis, the alternative, is in the form of a less than. I'm going to change this to 0.1. All right, so everything's set up. So now we need to find what our fence line is. So our fence line here occurs at negative 1.28. So here is negative 1.28. This is the line in the sand. If your test statistic falls over here, reject. If the test statistic is less than negative, let me repeat that. If your test statistic is less than negative 1.28, it falls to the left of negative 1.28, reject. If your test statistic falls over here, that means your test statistic is greater than negative 1.28, so you will fail to reject. So notice our last one is a two-tailed test, and with the two-tailed test, we have to split the area up because this is a statement where we're taking a look that it could be greater or it could be less than. All right, so for a two-tailed test, the alternative is in the form mu is not equal or mu1 minus mu2 is not equal. So that is a two-tailed test. All right, so that means if we have two-tailed and if our alpha level is 0.01, then that means in the left tail we have to have half of that, and in the right tail we have to have the other half. So notice on a two-tailed test, we divide the alpha area by 2. So that means that alpha area is going to be 0.005. So let's go ahead and clear this one out. And let's go ahead and make this 0.005. Now, before I click compute, I do want to mention that right now I have this set up to do the lower tail, to find the fence line in the lower tail. But you got to remember, simultaneously, you will have the fence line in the upper tail. So when I compute this, notice it says our fence line occurs at negative 2.58. So that means that when I take a look at this, actually right here is a fence line. And then notice right over here at 2.58 up here is also a fence line. So this area is 0.05. This area is 0.05. So if your test statistic is less than negative 2.58, or if it's greater than 2.58, then you reject the null hypothesis. If your test statistic is somewhere between negative 2.58 and positive 2.58, it falls in this non-rejection region, then you fail to reject the null hypothesis. All right, so now let's go ahead and switch our attention over here to finding critical values for hypothesis regarding means. Now, in this case, we're going to find a t critical value. So note, I'm using degrees of freedom, but if you're given a sample size, don't forget that it's going to be degrees of freedom is n-1, unless you have a 2 independents, then you choose the smaller of the sample size and subtract 1. So let's go ahead and do this. Notice, in this case, we're going to come over here to stat calculators. We're going to choose the t. So in this case, our degrees of freedom is 10. We have an upper tailed test, so I'm going to go ahead and change that. I'm going to clear this out because that's what we want. And here I'm going to put 0.01. Okay, so now we want the fence line for the upper tailed test. So I click compute, and notice on 10 degrees of freedom, right here is my critical value, which is 2.764. It's kind of popular to go 3 decimal places when we are referring to critical values for the t distribution. So 2.764. So again, if your test statistic is bigger, you reject. If your test statistic is smaller, then you fail to reject. The next one is a lower tailed test on 15 degrees of freedom. So I'm going to flip my inequality. I'm going to clear this out because that's what we want. And we're going to put our alpha of 0.1. And then I'm going to go ahead and click compute. So at alpha is 0.1. Notice on our left tailed test, we have a critical value of basically negative 1.341. So again, if your test statistic is smaller than negative 1.341, then you reject the null. If it's greater than, then you fail to reject the null hypothesis. And finally, if you have a two-tailed test, again, as we just saw, we have to cut that alpha area in half. So let's just note that half of 0.05 is 0.25. So with degrees of freedom of 9, I'm going to change this to 9. I'm going to delete this out. And then I'm going to go ahead and do the I did the lower tail the last time. I'm going to do the upper tail. And then this one here is going to be 0.025. All right, so then we go ahead and compute. So notice this comes back, and don't forget our critical values is actually 2.262 and negative 2.262. So that way, if your test statistic is less than negative 2.262, or if your test statistic is greater than 2.262, then you will reject the null hypothesis. If your test statistic falls in between negative 2.262 and positive 2.262, then you fail to reject the null hypothesis. All right, I hope this video helps on computing the critical values and how you will apply those in your hypothesis testing. As always, adios, and I will see you in the classroom.